Hello, welcome to PhyzQuest. So this is the video solution for CSIR NET December 2019 Part C, question number 11. The question is, the Hamiltonian of a system with 2 degrees of freedom is given as h is equal to q1 p1 minus q2 p2 plus a q1 square, where a is greater than 0 is a constant. The function q1 q2 plus lambda p1 p2 is a constant of motion only if lambda is 4 options are given and we need to choose the correct value of lambda here. So this question comes from the section classical mechanics and the concept involved here is Poisson's bracket. So in this question there is a Hamiltonian is given and a function is given with the condition that the function is constant of motion. At certain the value of the condition we need to find out. So first of all, what is a constant of motion? The constant of motion is, you can say that is the quantity which is conserved throughout the motion. Now here, this is a literal statement, but mathematically how you to identify that it's a constant of motion, a certain quantity is constant of motion? The best way is that the total time derivative of that quantity is equal to 0. That is the correct way to find out whether a quantity is constant of motion or not. So here, suppose we have a function is f is a function of position, momentum and time. So now if we try to calculate its total time derivative, that is df by dt, it will be equal to the since it's a the function is it's a function of time as well as position and the momentum. So the correct definition of total time derivative will be the sum of the partial derivative, that is del f by del t plus summation over del f by del q into del q by del t plus del f by del p into del p by del t. That is the total time derivative expression of the given function, which is a function of position, momentum and time. Now what we are trying to do here is, our purpose is to establish a relationship between the given function and the Hamiltonian. So there are two Hamiltonian equations. So using the Hamilton's equation, that is q dot is equal to del h by del p and p dot is equal to minus del h by del q. Using both these equations in this expression, see here, this is q dot and this is p dot. So in place of this, if you use this expression, that is del h by del p and minus del h by del q, and apart from that also using the definition of the Poisson's bracket. What is the definition of Poisson's bracket? So you see, if you try to calculate the Poisson's bracket between the function f and the Hamiltonian, it will be equal to del f by del q into del h by del p minus del f by del p into del h by del q. So first of all, putting this Hamilton's equation in place of these two terms and then using the definition of the Poisson's bracket, ultimately you will get the expression of the total time derivative of f will be equal to del f by del t is equal to df by dt is equal to del f by del t plus the Poisson's bracket of f and h. So this is the required relationship we have got between the total time derivative of a function and the Hamiltonian. Now in the given question, the Hamiltonian expression is given as h is equal to q1 p1 minus q2 p2 plus a q1 square, and the given function f is equal to q1 q2 minus lambda p1 p2. So here in our purpose is to find out the value of lambda in this function. So here the condition is given that we need to find out the value of lambda at constant of motion of this quantity. So at constant of motion means, at constant of motion, as I said, it is df by dt is equal to 0. The total time derivative of the quantity should be 0. So when this is equal to 0, that means del f by del t plus Poisson's bracket of f and h is equal to 0. Now if you look at the expression of f here, f is a function of only position and the momentum. There is no mention of time here. That means we can say this is f is not a function of time. Therefore, the partial derivative of the function will be equal to 0. That means ultimately we will get at constant of motion, the Poisson's bracket between the f function and the Hamiltonian will be equal to 0. So now what we have to do it, we have to write down the expression of this, and then we will solve it. So now here, before expanding, remember that here both f and h are functions of, they have 2 degrees of freedom. That is, there is a mention of q1 q2 and p1 p2. So the expression you will write here, this is, we are considering a single degree of freedom, that is only q1 p are mentioned. But when there is a mention of q1 p1 and q2 p2, you have to write down the extended version. That is, one set of for 2 degrees of freedom there will be 2 set of expansion. So this will be like this, that is del f by del q1 del h by del p1 minus del f by del p1 into del h by del q1 plus del f by del q2 into del h by del p2 minus del f by del q2 into del h by del q2. This is the expanded form here. So we have write down this set for q1 p1 and another set for q2 p2. So this is equal to 0. Now we have the Hamiltonian and the function are this. So when we take the partial derivative and write down the answer here, calculate the derivative, so it will be del f by del q1 is equal to q2. Similarly, del h by del p1 will be equal to q1 minus del f by del p1 is equal to minus lambda p2, this will be lambda p2, and del h by del q1 is p1 plus 2a q1. Similarly, the second one, the second set of this, it will be del f by del q2 is equal to q1, then del h by del p2 is equal to minus q2, minus del f by del p2 is lambda p1 and del h by del q2 is minus p2. So this is equal to 0. So this will be equal to q1 q2 minus lambda p1 p2 minus 2a lambda q1 p2 minus q1 q2 plus lambda p1 p2 is equal to 0. So here we have q1 q2 and minus q1 q2, this will get cancelled, and there is minus lambda p1 p2 and plus lambda p1 p2, they also get cancelled. So ultimately you will left with this term, which means 2a lambda q1 p2 is equal to 0. Now q1 q2 p1 p2 cannot be 0, and a is already given in the question that it is greater than 0. That means we are only left with lambda. So which says that lambda is equal to 0. Now let's check the option. Now if you check the option, you can see that option A is matching with our result. So correct answer for this question is option A.